Hello, everyone. Good evening and welcome to tonight's webinar. I'm going to give everyone a minute to jump on board here, give people a couple minutes, but we will get started promptly here. All right, it looks like people have slowed down joining, so I'll just get started here and the rest of the people will jump on when they do. So thanks everyone for coming and welcome. I'm pretty excited for tonight's program. I'm very keen to hear what Joe has to say. He's done a lot of cool work and we've helped out with some of his work, so I know a little bit about it, but I'm excited to learn more. But before I introduce Joe, I just want to talk a little bit about some of the stuff we've got going on here at GVBO. And I suppose I should introduce myself as well. My name is Ned Bowman. I'm GVBO's outreach coordinator. And so I put together events like these. And we've got some fun events coming up that I'm excited about as well. We've got a opt outside bird walk on Black Friday, which we started as part of REI's opt outside initiative. So we're doing a little bird jaunt around Reno and hitting all the hot spots. And we generally have a pretty fun time with a pretty low key crowd. Been doing it for a few years now. We have a webinar about gull identification on December 5th. Myself and Lauren Harder are going to wish they all could be California gulls. And so we hope you guys might tune into that as well. Then in January, we have a webinar series. Every Tuesday evening in January, we will have presentations for you. And details on that are still being developed. So stay tuned for announcements on that. Lastly, in terms of events, there are a number of Christmas bird counts coming up, which are a great way to get involved with community science and to connect with birders in your community. I've posted a number of them to GBBO's events calendar, and I believe the local Audubon Society chapters post them on their calendars as well. But take a look at that if you're interested in getting involved in connecting with some more birders. Especially now that we've got some fun winter birds showing up. I've been seeing rough-legged hawks. I was out at Carson Lake today and I saw a short-eared owl, so that was kind of cool. Had a number of white-throated sparrows this winter. There's scoters showing up around Reno, so a lot of cool winter stuff. Cool time to get out and see what's moving. We also have all of our 25th anniversary merchandise on sale right now. 2022 was GVBO's 25th anniversary, and Jen Ballard designed some really cool graphics that we put on t-shirts and water bottles and all sorts of fun stuff. So you can find all of that on our website. And you can also sign up for our mailing list and membership program on our website as well. So I'll punch our URL into the chat here shortly. But without further ado, I'd like to introduce tonight's speaker, Joe Barnes with the Fish and Wildlife Service. He's been researching raptors in Nevada for many years now and has done a lot of cool stuff, and he is going to tell us all about it tonight. So without further ado, I'm going to shut up and hand it over to Joe.
All right, well, thanks a lot, Ned. Let me, in this era of COVID presentations, let me get going with a kind of my virtual presentation here. Making sure, so you see my slides right now?
Yes, I can.
Take that as an affirmative. Yep. Okay, so yeah, my name is Joe Barnes, as Ned mentioned. I've been doing raptor work and other bird work, but primarily raptors for almost the last 20 years in Nevada and elsewhere in Western US and actually Western North America. And for about the past 13 of those years, I've also, along with some other species, I've been really delving into and doing a lot of golden eagle work. Some of that's ranged anywhere from Baja, Mexico, all the way up to a project up in Alaska and even northern Canada, right on the shores of the Arctic Ocean. But today, of course, we'll be focusing on golden eagles in Nevada, and really, kind of trying to highlight or just get you thinking about how they're doing in Nevada, but also in consideration and with some of the large scale landscape developments, and with a particular emphasis of renewable energy projects in the state. So before I get going, though, I do want to give a big shout out to Nevada Department of Wildlife, NDOW, aka NDOW, and also BLM, in particular the Kellyanne Field office and the state office, for really, really critical support for my work. In the case of BLM, it's been funding support for transmitters and help with logistics and all that. NDOW has been absolutely awesome and has supported me every step of the way. So I want to thank those two agencies right off the top, so I don't forget. So I think, we all need, what I want to start out with is the idea of, in this day and age, we need to really think about, when you're wanting to conserve wildlife or ecological systems, you have to really think about a balance of competing considerations. We have, and with today's economy and our population size and all that, there's going to be trade-offs. It's just a reality. And so if we want to have things like cell phones and laptops and the ability to travel on a whim, we use resources, and we need power, and we need energy. And so that's one of the things I try to keep in mind moving forward. I mean, it's to enable our way of life, but at the same time minimize impact and conserve wildlife to the best of our abilities. But you have to understand there is going to be a trade-off, and there's going to be this balancing act. So the way I want to kind of get going here is, for one, to start off, is just looking into the golden eagle natural history, kind of what makes them tick as a species, but also how they operate and how they're doing here in Nevada. And next, and after that, kind of launch into some of the considerations with landscape and development and resource extraction. So if you look on the right-hand image here, this is a map of the range distribution across North America. And kind of the purple polygon that you see across Western North America, that is their year-round distribution. I just show it here in the highlighter, and it's from Mexico on up into southern Canada. And that's pretty much encompasses all of Nevada here. And what we experience in Nevada is a fairly large year-round breeding population, but we also have a fairly large influx of migrants and wintering eagles from further north. If you start looking to the eastern half of the continent, you have breeding up in far northern Canada and far eastern Canada in some locations, but for the most part across the eastern US, they really only exist as migrants or wintering birds. But I do want to point out, just because we have them across Western US doesn't mean they're exactly easy to spot or easy to survey. They're for such a big bird, they're fairly reclusive. And they don't congregate nearly so much as the more well-known bald eagle. They're not nearly so gregarious, and they're certainly not very vocal. So with that, just kind of, they do exist across the northern hemisphere, and so it's not just a North American species. They're in Asia and Europe and elsewhere. But this kind of just paint the picture here. They are, one of those classic territorial apex avian predators. And all that means, the territorial portion of that means they require a territory or home range in which to breed and forage for themselves. So they need nesting substrate and they need foraging substrate, and those are two key components of a territory. And they defend that. Their territorial behavior is that's basically how they exclude others from hedging in. And the idea of being an apex predator, that means they're basically king of the hill, or top of the food chain in a way. Not many things will prey on a golden eagle, in some cases, a sick or injured eagle on the ground, or a very young eagle that took a pretty poor choice in roosting location, they could potentially be subject to predation by things like mountain lions and wolves and coyotes and things like that. As far as avian predators, there's not much that will take a golden eagle, but occasionally great horned owls will take nestlings in particular. And then there's also a risk of other eagles, bald and golden eagles. There's some risk there, predation. So even though they are kind of top of the heap in the avian world and the wildlife world, they are really prone to disturbance and fairly reclusive, and they're highly vulnerable to human disturbance. And so things like that could be recreational disturbance, things like rock climbing and off-road vehicle use, landscape development in the form of urban development and housing, and also industrial scale development, mining and other efforts. And so they really don't tolerate disturbance very well. And so there's potentially a direct mortality risk, but more often than not, there's the disturbance risk in which it just kind of pushes them out and they abandon territories. And over time, that effectively reduces local breeding population size. They have these lifelong pair bonds, and they tend to be long-lived. So in the wild, you can have adults that are 20 plus or even 30 plus years old. But you pair that with a very slow breeding output and high parental investment. And so that means that their breeding season's very long for most birds. It's about 6 months or so in our area. Courtship really ramping up in December and January, and then individual nestlings leaving the nest by June and early July. But even beyond that, the parents keep looking after the young. They teach them to forage, they protect them. Usually on average about 2 months after the young leave the nest, but that can range anywhere from 1 to up to 8 months that I've seen anyways. So that's a lot of parental investment, a lot of calories used, and they're really staking a lot on breeding. And because of that, they also, when times are rough and you have extreme drought or lack of prey, they'll also just completely forego breeding in certain years. And that's kind of a critical and important component of the ecology of eagles in this area. In Nevada, they're pretty much reliant on cliffs and open flats for their territories and their home ranges. There are some instances of them breeding in trees, nesting in trees, but that's pretty rare, very rare. But primarily you need these cliffs, and that's a nice protected substrate for nesting. And then they utilize the open flats, usually with pretty wide open vegetation and open terrain, for foraging and acquiring prey. Now, sorry, my pointer's getting the best of me. What I want to balance here, or just get you thinking about, is now juxtaposing their needs and how they make a living and how they survive with humans' needs for renewable energy and raw material extraction. And really, renewable energy it comes in various forms. But it's confronting today's reality of climate change and global warming, and trying to get us off of the reliance on carbon-based economy and industry. It has a benefit of minimizing our reliance on oil price fluctuations, particularly notable right now with Russia's in the Ukrainian war. And also there's a strong need as far as regulation and legislative need to meet US energy needs. A lot of states have been mandating thresholds for renewable energy use. And the state of Nevada, we're currently at a 50% threshold that we're mandated to attain by the year 2030. And so you kind of have to know that to get to those levels, you need some form of development, whether that's solar, geothermal, wind, whatnot. But also, you really can't talk about large-scale landscape development in Nevada without at least giving a nod or discussing mining. There's precious metals are mined in a very big way here in Nevada with gold and silver, but also other raw materials, things like lithium and perlite and various other hard rocks that are extracted for oftentimes industrial growth and whatnot. I'm going to get rid of the pointer because that just messes me up. So yeah, moving forward. So hard rock mining. What you see here in these two images, a couple examples of mines in northern Nevada. And these typically tend to be sited in mountainous regions or in the foothills. And so in this case, you have a bit of a pressure on eagles as far as nesting substrate. Entire cliff nests sometimes are subsumed. I will note that when some of these mines run their course and are left are abandoned, some of these high walls actually become nesting substrate for eagles moving forward in the future. So they can kind of recolonize or repatriate some areas. But most of these projects are not occurring out in the open flats. So they're not necessarily a direct threat to foraging as much as they are to nesting. Wind energy developments are a little bit different. We don't have a ton of pressure for wind energy developments here in Nevada yet. There are increasing numbers of permits that I'm aware of that are for potential development, but at least at the moment, there's only one facility operated on public land, and that's in eastern Nevada. You see that in the upper middle image here. And at least in Nevada, the development of these projects tends to happen in the open flats or on slopes, not in the high topography, not in the cliff areas where it would be more, focused on nesting behavior. And so it impacts foraging habitat, but it also adds this new element of direct mortality risk. Eagles and other birds out there flying and bats and things like that being hit and struck by spinning turbines. And then there's solar. And that's going to be the kind of my biggest emphasis of this talk. And that's really because the need or the desire, the growth of the solar industry is just booming in Nevada right now. It's really, to my knowledge, really started about 15 to 20 years ago. And pretty much every year, development pressure increases. A big part of that is to meet that 50% threshold. But just some examples of what I'm talking about here. In the early days, a large scale solar project would be in the order of 1,000 to 2,000 acres. Now we're looking at 5 or 7, up to 7,000 acres for an individual project. And oftentimes, more and more, we're getting projects basically stacked one on top of each other. And so overall complexes might be as much as 20, 30, or even more 1,000 acres. And so that is a huge landscape modifier. And what we see in the upper image here is, I don't know if you can see my cursor or not, but this is a traditional photovoltaic project. And what happens is you basically bulldoze the topsoil and you essentially sterilize the landscape. There's a fence that goes up so wildlife doesn't come in or out. It's not a direct mortality risk to eagles, but it does impact foraging space and home ranges. And it also takes off a lot of acreage for support of prey base, things like rabbits and other smaller animals that can be eaten by eagles. One thing to kind of note is this range of this ridge line and cliffs in the background behind that photovoltaic site. That is just absolutely classic golden eagle nesting habitat. And so you see they'll nest up there in those foothills and cliffs, and then they'll come down in the open flats for foraging. The next photo down, that's a concentrated solar facility in central Nevada. And you'll see that center tower there. That's where basically the energy and from the sun hitting all of these collecting mirrors concentrates around that tower. It's a power tower. And so now you actually introduce, in addition to landscape modification, you now introduce the risk of direct mortality through way of burning and incineration of birds, and it's anything from small passerines up through eagle-sized birds. And then down below, there's kind of a combination of the two. This is a project area just over the border in California. But again, you see this kind of glowing orb down there, and that's another power tower. There's just absolutely classic eagle breeding habitat behind that. And then in the foreground, there's a photovoltaic field. So just really large scale habitat modification plus with some direct mortality risk. So to kind of now focus more on eagles, looking at the golden eagle context, kind of in the state of Nevada. First, I want to touch on their distribution. So within the Nevada Department of Wildlife's raptor nest database, we have a bit over 6,700 raptor nests. Almost 1,300 of those are either confirmed eagle nests or possible or likely eagle nests. So they're widely distributed. Again, we're just, most of you probably are really familiar with Nevada, but those that aren't, we're a really mountainous state, but most of the state is composed of broad, wide basins with surrounded and separated by mountain ranges. And every single mountain range just has, prime habitat for eagles and other various cliff nesting raptors. The overall statewide population estimate ranges from 2,400 up to 3,000 individuals in Nevada. That's with a really large confidence interval. It's hard to get a true handle on eagles in Nevada and elsewhere in the West. Just because they are so reclusive. They're widely distributed, we know that, but they are hard to survey on a grand scale, and it's hard to access a lot of these locations. So we end up having to extrapolate and interpret, small, either coarser data or small scale studies like I'm going to present here. And there have been various studies showing possible west-wide declines of golden eagles, or either a stable population or a potentially declining population. That's not set in stone, and there are others. There's competing studies that basically indicate they might be increasing, but it's just the confidence intervals are really, really large, and it's hard to have a good, solid understanding of what their status is. I know you all are here to talk, hear about golden eagles, and certainly that's my forte. But you also have to kind of think about impacts, at least on some level, of a host of other wildlife species, things like Mojave Desert tortoise, federally threatened species in the Mojave Desert, in the upper right here. And then in the center, you've got Lacan's thrashers, a fairly imperiled bird of conservation need. Also existing in the southern fifth of Nevada, basically the Mojave Desert region. On the lower right, you see pale and dark kangaroo mouse photo. Those are two species that are highly range restricted and endemic to the Great Basin and or Nevada itself. And they tend to exist in these lower basins, and so they are highly vulnerable to impacts. And then sage grouse. They're highly dependent on intact sagebrush ecosystems and very vulnerable to fragmentation and landscape disturbance. And then even bighorn sheep over on the lower left. You don't necessarily think of bighorn sheep as being impacted by valley development, except in particular with younger males, you absolutely need connectivity between mountain ranges for just as far as dispersal goes and population and genetic connectivity. And that can be compromised when we get these massive landscape development projects. So there is regulatory protection for eagles, both within Nevada, but also nationally. You have, number one, first and foremost, the Bald and Golden Eagle Protection Act, of which golden eagles were added to join their distant cousins, bald eagles, in 1962. You also have the Migratory Bird Treaty Act, which covers most migratory birds, and that was initiated in 1918. It also covers golden eagles. That's a treaty signed between multiple nations. So it's the United States, the UK, in the form of Canada, and also Mexico, Russia, and Japan. So it's a fairly complicated, detailed act, but it has implications here. And then within the state of Nevada, this isn't necessarily regulatory, but they are listed as a species of greatest conservation need in our Wildlife Action Plan of 2012. A little hint there that we've actually just revised it, but it has not been finalized just yet. But there'll be a new action plan here in a matter of months. But conservation challenges that were identified 10 years ago, that included things like that I've already mentioned, but they're vulnerable to prey reductions from habitat loss, wind turbine collisions, human disturbance, and also this thought that they are likely declining in the Western US. And so it's just that the action plan helps guide our and our sister agencies' efforts, and basically to further conservation causes for various wildlife species. So my study areas, to kind of peel back the layer of the onion and kind of get back into, what I'm truly doing and what I really want to present to you, the data that we've been collecting. The work I started with Endow began in 2014. That first year was really a pilot year. So most of the calculations you'll see later, it's skipping 2014. That was really the year I was getting my feet under me. And so that data isn't really nearly as rigorous as what was collected in later years. So most of the, when I'm looking at breeding success, it's usually 2015 to the present, 2022. But this study area in the oval in southeastern Nevada, the red oval, that's in Lincoln County, and it's this Dry Lake Valley study area. That's my primary region of study. It's focused on a solar energy zone that's a designated solar energy zone that has not yet been built out. So you see in this lower image, this lower picture on your screen, that's actually pretty much from, well, me sitting right in an eagle nest and looking out into the Dry Lake Valley. So you see largely an undeveloped, fairly undisturbed landscape. There is cattle grazing, there's 4 different grazing allotments in the valley. But it appears to be fairly sustainable and not detrimental to the eagles. And so that was one of the reasons, that was one of the impetus, kind of the trigger points for getting that study going, is the solar energy zone and trying to get true baseline data before development. And so one of the other pieces was direct communication and coordination with the local BLM office out of Caliente, trying to provide some input and feedback on potential impacts that off-highway vehicle events, things like races, in this open valley, what those impacts might be on the local eagle population. And then there's a series of 4 secondary study areas that you'll see in these green ovals across the state, primarily focused on assessing territory occupancy from 2015 through 2018. There's a total of 28 territories there. And it's on the screen, but just to note that there are 18 known breeding territories in that primary Dry Lake Valley study area. And it's a gratuitous kind of tongue-in-cheek, but you'll notice this oval here. It's because about 3 years ago I moved to Reno, and now I'm always on the lookout for potential expanding what we know about eagles and closer to home in my backyard. And so I'm oftentimes I'm always very interested to hear from local birders and wildlife professionals, as well as just folks out hiking, if you've got any hot tips, or also want to be involved in any projects in the future with helping to monitor nests or help banding, things like that. So the study goals, and this really does focus on that red oval. This is really what the heart and soul of this project was focused on the Dry Lake Valley study area. So initially, understand the local population dynamics, and that's looking at things like population size, breeding density, and also breeding effort, whether or not they breed in a given year, and then if they do breed, were they successful, and how many young did they produce in that year. Understanding habitat use, and we get at that by using not only looking at where their nests are located, but using satellite and cellular transmitters, deployed backpack units on these birds, where you can get hourly or sometimes even 15-minute fixes, and you see how they use the landscape, not only terrain as far as valleys and mountains, but you can tease it out into avoidance of roads, things like that. And then also whether looking for, say, sagebrush habitat versus forested areas versus open playas or sparsely vegetated desert flats, things like that. And not necessarily in order of importance, but I'm also looking at estimating and determining what their breeding season diet is, to see what they rely on during the breeding season, what sustains their population. And then also looking at age class survival rates in the form of juveniles, which would be that hatch year, first year of life, subadults, and then adult. And they attain their adult plumage in their 4th year. So it's basically 4 years and up would be adult age class. those secondary study areas, again, I've used them to augment what I know about the demographic study in the Dry Lake Valley area, which really helps me get an understanding of whether or not that's just a unique situation in southeastern Nevada, or it truly is representative of what's going on across the state. I guess helpful, like a pointer, is that indeed what we see in Dry Lake Valley is fairly representative of elsewhere in Nevada. But they've also been very handy as transmitter recipient sites. And so when I have transmitters to deploy and I can't get them out on birds in Dry Lake Valley for one reason or another, lately that's because of extreme kind of crash and breeding effort or breeding success, I've oftentimes had to look to these recipient sites, these other secondary sites, to get transmitters out and collect data for a given year. I'm always looking to tie in the status of eagles to climatic conditions and also things like prey availability. And so when presenting this data, the data that I've been collecting, I'm always, you need to understand context. And this is all essential when you think about if you're going to assess impacts from renewable energy production or development or any other landscape development effort. You kind of need to know baseline, and you need to know what's going on in otherwise undisturbed habitat. And so that's all kind of tying in together. And one thing that you might have all missed, it got definitely low on the media coverage based on the year that it hit, but the rabbit hemorrhagic virus disease, or HDV2, hit in 2020, also the year COVID made its biggest splash globally. And it just absolutely it has profound impacts on local rabbit populations. It's not native to North America. This virus was previously not found here, but it's extremely virulent and with high mortality rates of anywhere from 50 to even 90+% mortality in a given population. And so that has really big impacts on rabbits, things like jackrabbits and cottontails, but also species that rely on them for prey. So now to look even closer into focus on that Dry Lake Valley study area. It started in 2014 and has been ongoing every year up through 2022. And the overall study area is just over 930 square kilometers. It exists in kind of this transitional ecozone. It's kind of the boundary between the Mojave Desert, the lower fifth of Nevada, and the Great Basin Desert, which is central and northern Nevada. And so this study area overlaps the two. You'll note this red polygon in the middle here. This is the designated solar energy zone. It's just over 101 square kilometers. I believe that's 21 to 24,000 acres. And it's designated, but it has not been built out yet, and maybe not in the future. I don't really know. But at this point, that's a useful area to look at when you really consider where the eagles exist. And if it does get built out, we'll be able to then assess response of eagle territories and the overall local eagle population. So again, there's these 18 territories. Those are represented by these blue thumb tabs that you see on the map. And you'll note these mountain ranges. This is typical. The open basins isn't generally nesting substrate or nesting habitat. That's largely where they do their foraging, but they nest in the foothills and mid-elevation cliffs on some of these mountain ranges. To some extent in the higher elevation cliffs and the tops of mountain ranges, but definitely more frequently on the outer edges of mountain ranges. The overall average distance of these nests or these territories to the solar energy zone is just over 6 miles away. But that ranges from under a mile, at 0.7 miles, all the way up to 18 miles away. And you compare that with the overall average distance between neighboring nests or neighboring territories of eagles. The average distance is 3.5 miles between territories. And you can use that as a surrogate, kind of a way to estimate general territory or home range size. Because they are territorial, they exclude other eagles, other adult eagles from their nesting areas, but also kind of their key foraging areas out in front of nests and surrounding nests. And so that when you look at that surrogate, that 3.5 miles, which ranges anywhere from just under 2 miles to 7.5 miles, you think about how that also, that's the area that those eagles need to go out and survive. And so when you have large scale landscape modification, how might that impact them? And what I show here is these yellow circles, those are those depict that average home range or territory size. And you see kind of the amount of overlap, and wildlife doesn't exist. They don't follow our rules. They don't just exist within circles. And you see there's a lot of amorphous, oddly shaped territories, but this at least gives you something to look at and something to really start evaluating on what like particular projects, how they might impact eagles. And so to get a handle on in a real world, how individuals operate, not just use that kind of surrogate as a territory size, but now we're looking at these red dots. This is an adult eagle, adult female that was banded, and this is in with a transmitter. So these are data points spreading only about a 5-month period in the year 2018. And you'll see the same thing down on the eastern side, these blue points. And so this is a very small snapshot. In both cases, I think I had these birds transmitted for 3+ years, but we're just giving you a small representation of where by far and away the cluster of use points are closer to the nest and does kind of fall within this these the stand-in for a territory or home range. But you certainly have points outside of that range, and then they do kind of move around a bit. And so not going into formal analysis of data, but just to kind of show you a snapshot of how they operate. And this is what you see, honestly, this pattern is 12 months a year. Our eagles, our adult territory holders, tend to maintain and stay on territories year round and not disperse and not migrate big distances. And this is what we see with young birds. So these are fledglings, birds that eagles that have just left the nest. Typically, again, they usually stay within the natal area, usually at least a month. The overall average is about 2 months after fledging, but that can extend all the way up to 7 or 8 months. And so you'll see, at least initially, when they're not good flyers and they're highly dependent on their parents for protection to some degree, but also foraging and giving them food, they're focusing around the nest. But as they get better and better at flying, and before they actually go, they disperse, they start ranging further and further from their nest. And you see a bit of overlap. And so it really remains to be seen, what are the impacts of large scale developments in the face of, we start to get a snapshot of how eagles operate, and we know that they need large expanses of land. The next step is to really see what this type of modification does to whether or not they can persist over time. And now, so I showed you basically those juveniles, those fledglings, those are 1-year-old birds, and then adults, 4+-year-old birds. Now what happens in between? So basically your teenagers or your subadults, and that picture gets a whole lot more complicated. What I'm showing you here is just 1 year in the life of a subadult male. I actually had this bird transmitted for 5 years before his transmitter died. And so what I'm showing you here, these green dots, this is during the breeding season, January through July. And you'll note, for the most part, this is a northward movement pattern. So he started off in January down in Baja, moved up, spent a lot of time in Nevada, and then started bouncing up into Idaho and almost the border of Montana. By late summer and fall, the next 3 months, this bird spent mostly in Idaho and Montana, and then started dropping down again through Nevada and a little bit into Utah. And then during the winter months, headed from Utah down right back into Baja. And every year, over a period of 4 or 5 years, this is about the same pattern for this individual. That's not normal. A lot of times, Great Basin subadults stay at least local on some level within like multiple counties, oftentimes within Nevada or neighboring states. But there are some exceptions where they cover pretty vast expanses. And that has a lot of implications when you think about risk. And now you can't just think about one solar project or one mine. Now you're thinking about urban expansion, you're thinking about airports and power lines and all these risks and threats that those birds experience 12 months a year throughout their life until they attain a breeding territory. So thinking about occupancy, um, territory occupancy in particular, it's akin to a dog protecting its home or its yard. And so because we know that eagles don't breed every year, the timing of these surveys is critical. And so you have to get out there and survey the landscape before they lay eggs. And so that's primarily December through February in Nevada. And you're getting out there and you're looking for adults in the vicinity of nest cliffs and exhibiting courtship and territorial defense behaviors, and also nest building and maintaining existing nests. And what I've seen is even in the dire years, and you'll see a little bit later, the conditions have gotten very bad over the past 5 years. It's still every year after year after year. I mentioned these are very long-lived birds, and these individuals are still maintaining territories. You have nearly from 2015 through 2022, these are number of territories that are checked each year. And the territories that were occupied, it's 98.2%. So nearly 100% of the time, even when they're not breeding and even when they do breed, they're failing. It's yet to be determined what happens if conditions remain as bad as they currently are. I don't know, we don't really know. We don't have an answer for that. When you pull in my secondary study areas, those other 28 territories across the state from 2015 through 2018, it was 100% occupancy. And so it gives you an idea of how resilient these birds are. But as you look at breeding success and some of your mortality factors, it really remains yet to be determined how they'll persist long term. So now to look at that breeding rate and like some of these indices. Initially looking at breeding rate, and that's just of the territories that have monitored for breeding activity, how many of them go on to lay eggs. And when years are good, oftentimes it's close to 100% of them lay eggs. But more and more, especially since 2018, I've seen a drop off, and the lowest point was under 50% of them laid eggs in 2021. Not dire, it paints a picture. And how well, when they do lay eggs, what's your breeding success? And that just means of the birds that lay eggs and attempt to breed, how many actually produce at least one nestling that fledged and left the nest under its own power. And that ranged the first 3 years of the study from 71% up to almost 86%, which is quite good. Overall number of young per breeding attempt, it ranges from 1 to just under 1.5. You compare that to the last 5 years of the study, and now you're looking at breeding success rates of 37.5% dropping down to 14, and then 0, not a single territory produced young this year in 2020. The number of young per breeding attempt, instead of being 1 or greater, now is 0.6 down to 0.1, and essentially 0 breeding success and in these last 3 years. So if you combine those years and pool the data, the first 3 years, we had an overall breeding success rate of 78.3%. The second, or the 5 years following that, only 23% success. And then young per breeding attempt, 1.2, it dropped down to 0.28. So those last 5 years, it's definitely not indicative of a self-sustaining population, but it's a matter of what will happen if the conditions improve, and can they persist and hold off until hopefully that improvement occurs. Bringing in some drought data. This is just to give you a little, just an idea. This is data from the National Drought Mitigation Center, a collaborative effort between the University of Nebraska-Lincoln and also NOAA and the U.S. Department of Agriculture. But anyways, what I've done is I've brought in the data from March and also June. So basically when the eagles are doing most of their egg laying, and also when they're approaching the time period when they're young or almost about ready to leave the nest. And we're just looking at you'll see here the range of drought. These last 5 years is really actually the last 2 years, it really gets bad. We have exceptional drought in 2021 and extreme drought in 2022. And this is just specific to central Lincoln County in that Dry Lake Valley area. Just a quick representation of what that looks like in the West. And I'll draw your attention. Hopefully you can see my cursor. But Lincoln County is right here where my cursor is surrounding, and that's my study area. The Dry Lake Valley area is right in the center of that, basically. So when you're looking at this, the maps on the left is the March data, and on the right is June data. And so you see from 2015 through, and now this is 2016, that the drought situation's actually improved. 2017 was quite good across most of Western US. 2018, things are getting worse. 2019 was another pretty good year. Started off bad in March, but it definitely improved as the summer went on. 2020, decreasing a little bit, getting a little worse in the West. 2021 is absolutely horrible. Most of the West was under either extreme or exceptional drought conditions during the breeding season for golden eagles. And then in 2022 is a little bit better, but not a whole lot better. It's anywhere, most of the Western US is severe drought to exceptional drought. And certainly my study area, experienced those types of conditions throughout the entire breeding season. Okay, so what else? How do they make a living? I mentioned rabbits several times. And so you'll notice here, this is the diet that I've assessed over 479 individuals that I've identified either through prey remains collections at the nest when I go in to ban nestlings or after the breeding season, and also nest cameras that I've placed in. These are motion detection cameras. And I've identified what the eagles bring back during the breeding season. Almost 70% of their diet is composed of black-tailed jackrabbits, even when they're barely available. So rabbits, their populations have really dramatically declined, and somehow, I mean, they still persist on them and in some level, but yeah, it's definitely impacting breeding, but on some level, the adults are at least getting enough to continue. Cottontails, you'll see that's about 8% of their diet. So the two combined is approaching 80% of their diet. And then you have a whole series of other things. And so overall, there's 33 distinct species that I've identified as being preyed on by Nevada eagles. The next most predominant, they're all in the 2 to 3% range, but you've got kit foxes, gopher snakes, ravens, ground squirrels, and actually I lumped 4 different species of ground squirrels there. And then you have this other category, which is another 15% of their diet. And that's that's composed of 24 different species. And that's everything from great horned owls, red-tailed hawks, to deer fawn, mule deer fawn, pronghorn fawn, skunks even, a lot of different items. But the thing is, there's no way that all these others, they just can't, based on how they exist in the landscape, their density, they would not even come close to making up for the collapse of lagomorphs, of things like jackrabbits and cottontails. Another portion of this assessment is really kind of thinking about what is the existing mortality rates of eagles, not just in the face of like local development, but in this case, this is a meta-analysis by U.S. Fish and Wildlife Service in 2016, pooling data from age classes, so subadults and adults. Their causes of mortality, just over 44% is from anthropogenic or man-made causes, and then almost 56% from natural causes. And that breaks down into this type of pie chart. Starvation and disease and natural injury, again, those are the two kind of natural causes. When you look at anthropogenic, you have illegal shooting at 11%, electrocution at 11%, poisoning, almost a little bit surprisingly, still pretty high, collision, and that includes things like strikes by turbines, but also wire strikes into power lines, and vehicle collisions, being hit on roads, trapping, leg hold traps, which is basically accidental or incidental trapping. And then lead. Lead is a tricky one because it only came out as 2% cause of mortality, but it's exists, and many studies have shown that it exists in sublethal quantities within the bodies of eagles, and it is very pervasive. And so quite likely lead poisoning is some contributing factor to this, what we consider natural cause of death, starvation, disease, and things like that. A compromised bird is much more likely to be injured or die of starvation than a bird that didn't have any lead, for example. And so that's looking at big picture west-wide golden eagle mortality causes. Well, what do we see here in our study? So just looking at the tracked birds, those birds with transmitters, a total of 45 individual eagles were tracked during this report period. Hatch year birds, that's, and this is on the calendar year. And so birds, their first year of life after they left the nest, we've got almost 65% of them survive to their next calendar year. Second and third year, so these are kind of your subadults, your teenagers. A little bit surprisingly, they drop, not necessarily statistically significant drop, but it's still a pretty low survival rate for, as they get older. Part of that is they're existing now in this deep drought and low rabbit availability, and they no longer have their parents looking after them and providing for them. And then after third year, that's your 4-year-old and above, those are adults, and we see annual survival rates of almost 86%, which isn't too bad. And causes of mortality, the items here in red, those are the anthropogenic causes, and so as opposed to yellow, which is natural. And so you see starvation, hit on road, primarily that's winter months, and it's usually younger birds scavenging dead carrion on the side of the road, being hit by fast vehicles. Predation, that includes coyotes, and also in one case, a great horned owl took a golden eagle nestling after I deployed the transmitter, but before it could leave its nest. Then a couple of cases of electrocution, one of poisoning, and 13 unknown causes of death. And that's because it takes a lot these birds are out in far-flung locations. To get true cause of death, you need to get out onto that bird very quickly after it dies. And it's just logistically, it's very burdensome. It's hard to get out there. It's many hours of driving, usually tacked on to several hours of hiking. And it's just really hard. So 50% of my dead birds, dead eagles, unfortunately, I don't have a cause of death to attribute that to. And just real quick, how do our survival rates compare to west-wide survival rates? So what I show you here, this is a study that just came out. Our data did contribute to this overall west-wide assessment, but this is an analysis over 20 years looking at over 3,600 eagles with transmitters across the West. And so you see very similar hatch year success survival rates. Second and third year, you'll see in the national data set, bounces up into the mid to high 80s, which is quite a bit higher than we see. Part of it is probably the smaller temporal snapshot that I'm looking at, and most of my study has been under pretty extreme conditions in terms of drought and low prey availability. After third year, the adult survival rates, that's very similar, 89% compared to our 86%. So in summary, I'm sorry if I've carried over here, but really it's this very high annual territory occupancy, even when we're dealing with multiple years, 5 years of very low prey availability, and at least the past 3 years of very brutal drought conditions. The breeding success and productivity, that is how many young are produced per year, that appears to be tracking pretty closely climatic variables, things like drought, but also this primary prey availability, rabbit availability. Territory holding adults have these fairly high annual survival rates and also remain on territory year round. That's something that we did not know. It's really unknown what eagles did in Nevada on a yearly basis until we started getting transmitters out during this study. So this is a pretty major benefit as far as what we know about eagles in Nevada. broad dietary breadth. They take a lot of animals, but most of what they rely on are lagomorphs, things like jackrabbits and cottontails. And then a key thing is really thinking about RHDV2, this rabbit hemorrhagic disease virus, and what that, in a long-term sense, what impacts that might have on rabbit populations, and then correspondingly on eagle populations. And finally, seek ways, always try to seek ways to minimize development impacts on wildlife, whether you're looking at renewables, mining, whatever. We know we need to extract resources, that's just reality, but we can do things smart and we can do things to minimize local impacts. And what I show you here in the lower image, it's kind of interesting to see I have an industrial piece of equipment here, but this is basically a paradigm shift in how solar is being developed in Southern Nevada. It's really encouraging, extremely encouraging, that we're actually, if you look there in between these supports, these are supports to be able to support solar panels, they're maintaining the landscape. So instead of bulldozing and just eliminating all topsoil, they're maintaining the topsoil and maintaining the desert vegetation, which should theoretically, it's still, we'll find out over time. This is really happening, like breaking news. It's happening right now this year. But theoretically, things like rabbits should be able to persist in this type of environment. Songbirds should do much better. A lot of prey will have a much lower impact than what we see with the traditional photovoltaic approach of just like blading everything and making large scale parking lots, essentially. So with that, tons of people are required to make a project like this happen. So I want to say a big thank you to Jen Newmark. She's a Wildlife Diversity Division Chief at NDOW, and a whole bunch of other folks with BLM and others who have come out and helped me with my surveys and banding and all that. And then also, as far as agency support, definitely BLM, Great Basin Bird Observatory helped with transmitter purchasing earlier on in the project. And the Spring Valley Wind Technical Advisory Committee has helped with some of the secondary efforts. And also my beautiful wife, who has persisted throughout all this and supported me every step of the way. Big thank you to her. So with that, I will, if we have any time for questions, let's, I guess, go for it.
Yeah, thanks, Joe. That was very, very interesting, and kind of a dire picture you're painting there a little bit.
Hopefully not. I mean, we'll see. These birds do live a long time. And it's hard to say. We're in uncharted waters. I don't know if we're going to be coming out of the drought. We don't know what's going on with rabbit populations. It's possible that the adult territory holders persist, and then as conditions improve, reproductive success improves, and maybe it'll all come out in the wash. That is actually, I'll put in a little plug, and this is one of the reasons, extremely highly valuable reasons, why we need long-term data sets and long-term studies. A lot of times you'll get snapshots, and your typical grad school project might be anywhere from 1 to 4 years. And that's only going to get a small snapshot of what's going on. And so here we've got a 9-year data set, and even that is starting to approach a longer term data set, but it's just still such a small snapshot in the real world when you have all kinds of competing pressures, both natural and man-made.
Yeah, totally. Oh, I do see Rose is raising her hand. Hang on a sec here. You should be able to talk now, Rose, if you unmute yourself.
Hi, thank you. Joe, I was wondering if the rabbit disease, can you tell yet if it is declining, running through its course? Is it getting worse? And is there anything that we can do about it at this point?
Good, really great question, and hard I don't have a great answer. I do know, as recent as this year, a pygmy rabbit, population was pretty much decimated in central and north central Nevada. And that's a highly sensitive species. And so the problem is that, I guess that there are two sides of the coin. So one is we already had a very depressed rabbit population before RHDV2 hit. So that actually might lessen the impacts because it would slow transmission of the disease. You know, both like that first year of contact, but even year to year, it just, you know, just kind of like wearing masks during the time of COVID, it slows that transmission rate. And so that might be helping the situation. The virus is extremely persistent. So once it's in a population, unless they die out, it might, I don't know. I mean, we really don't know. There is some, I'll say, so for Nevada, we don't have a great answer. I don't know if it's getting better. When you look at jackrabbits and cottontails, it's hard to pick up dead ones on the landscape to know if they're still have the virus because they get scavenged so quick. And especially now that conditions are so awful, coyotes, anything that can is going to snatch a dead rabbit the first thing, you know, first opportunity it gets, vultures, ravens, things like that. So it's hard to really get a finger on the pulse of what's going on out there. There has been some recent information coming from New Mexico and Southern Arizona indicating some of their populations might be rebounding, their populations of rabbits. So there might be cause for hope there.
Great, thank you.
Joe, we've got another question in the chat. It just says next steps / plan. So I'll allow you to interpret that how you will.
Well, that's good. That's fairly open-ended. I will say one of the key steps that I've been working with some excellent partners with has been to broaden the kind of the assessment of what's going on with eagles and focus on large scale, in this case, solar development. So working with BLM out of the Southern Nevada field office and working with Fish and Wildlife Service, NDOW, USGS to try to basically it's down in the Mojave Desert, so it's a different study area than my Dry Lake Valley area, and so but it would be very comparable data, really looking at in the face of large scale development. And in that case, we're looking at 20,000+ acres also of if all the projects are built out, we would have very large landscape modifications. And it's also an area where some of these newer approaches towards developing solar, leaving vegetation on the landscape is also occurring. And so that's one of the key next steps is basically, and it's really getting off the ground right now as we speak, is to get a study going. And we can certainly use the existing data, these past 9 years of data as comparison, but basically do a deeper dive directly in areas experiencing large scale landscape development and see how the eagles adapt and modify. Otherwise, and so that's a key thing. And it's such a long-lived bird, you really need to keep these studies up for multiple years. And so it's really hard. You don't get instant answers on any of this, unfortunately. I will say I worked with tortoise a bit, desert tortoise, and they're a whole lot longer lived than eagles, and that's even more frustrating. But the two species are not easy. It's not like you're dealing with a small rodent that might have 1 or 2 broods per year. I mean, it takes a long time for things to happen. And so really kind of the next step is to just keep on looking and try to make where we look strategic as possible to be able to use that data to then apply to the real world and you know, minimize impacts and truly assess impacts.
And I'll kind of echo some of those thoughts. What do you think about things that people can do that are not agency biologists, not researchers, not folks that are on the ground involved with these development plans, that are not in a position to guide the direction and development of these, but people who are attending this webinar thinking, well, what can I do? Do you have any thoughts for folks like that? How can people get involved?
I mean, part of it is reach out to myself, reach out to others. You know, if you're in your wildlife conservation community, whether it's NDOW, BLM, Fish and Wildlife Service, GBBO. GBBO has an absolutely excellent, you know, volunteer network and citizen scientist, you know, organizational structure. And honestly, you know, wildlife science and conservation is oftentimes operating on a shoestring or you know, relatively underfunded. And so sometimes it's a matter of getting involved, looking for opportunities. I'll do my best to reach out to folks. I don't know, Ned, I don't know if you can plop in my email, but basically helping nest monitoring, or when you're out there hiking or climbing or bird watching, report nesting locations of some of these species. And that can be, I will caution you though, like putting in nest locations, like detailed locations or with fine scale photos on social media can often backfire and puts those birds in direct risk of high disturbance. And so it's really, if you know, to get involved, it's really to, you know, definitely it helps for on individual levels, but try to feed into, you know, kind of wildlife professionals that, you know, kind of take into account potential impacts to the birds and try to minimize that as much as possible.
Yeah, great. And so I'll just confirm, you do want me to paste your email address into the chat box? Get your okay on
Yep.
that?
Yeah, if you
Okay,
can.
cool.
Yeah, just because
Yeah, absolutely.
I'm
Yep.
a little scattered. I'll probably do a typo since I'm.
Nope,
I noticed.
just confirming.
Yeah. I pulled up that Q&A box, and so I just,
Oh yeah,
as
we've
you're
got a
typing
couple
that,
more in
Ned,
there.
yeah, I noticed one of the questions was the Audubon Migratory Bird Initiative database. And absolutely. So every single one of the birds that I've deployed transmitters on in Nevada, that data has gone to, and it's in that. So if you go to the Audubon Society website, there's a migratory bird initiative, and it's an absolutely awesome website. It's got tons of, I don't remember how many species are represented, but it shows movement data on probably 100 or 200 species across North America at least. And so all my golden eagle data is in there. All of, I shouldn't say my, but NDOW's golden eagle data. Also other work that I do, it pretty much all goes in there. Phrygian's hawk, I do focus studies on those. That data has gone into that database. Northern goshawk work that we've done with one of my colleagues out in Elko, that's gone in there. And so, yeah, I think that's a good question, because a lot of times we can be guilty of working in silos or working in boxes or bubbles. So sharing what we find with the broader community, both research community, but also the public, I think is hugely helpful for overall conservation of these species. So, yeah. Yeah,
absolutely. Well, I don't see any more questions coming in. I'll give folks another couple minutes, but I say again, I really appreciated that. That was a really interesting talk. And so we did record tonight's program, and it will be available on GBBO's YouTube channel in a couple days here, once I get to uploading and posting that. Okay, well, then, yeah, I don't see any more questions, so I guess we'll go ahead and sign off, but I'll just highlight some, just quickly plug, community science is just a great way to get involved, and Joe is getting at that a bit too, that we're all operating on these tight budgets, and we could always use more help from more willing volunteers. So you've got Joe's email address in the chat, as well as the GBBO web address in there, and you can get in touch with us, and you can get in touch with Joe via those platforms. So thanks for attending, and if no one has any more questions, I'm going to go ahead and sign off.
Thanks a lot, everyone. Glad for the opportunity. Thank you, Ned, for reaching out.
Yeah, thanks, Joe. All right, well, have a good night, everybody.